So we're moving on today to the tangent function. You may have asked yourself, why didn't that show up the other day when we were just doing sine and cosine? Or, then again, maybe not. So the tangent function on the unit circle, how does that come into play? Let's dive right into it. P is a point on the terminal side of the angle that intersects the unit circle. Okay, well, looking at this right here, I've got my unit circle. Awesome. Where's my point? Oh, right here. Let's look at an easy point. The point 3/5, 4/5. Okay, so that means I went over 3/5 of the way, and then I went up 4/5. And this is cosine. So we can look at it two ways. We can make this into a triangle. And we can look at this and say, this is a unit circle. So this radius is 1. And this side must be 3/5 because it's the x value. And this side must be 4/5 because it's the y value. Then here's my angle right here. And the sine of that angle is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse. So tangent. Tangent is found by taking the opposite side and putting it over the adjacent side. Okay, so let's look right here. My opposite side is 4/5. My adjacent side is 3/5. And I just know when I'm dividing fractions, I have to multiply by the reciprocal. So it comes up as times 5/3. So the tangent ended up being 4/3. And that's how you find the tangent. So we have something new, and I want this written down in big notes in your notebook. The tangent of any angle can now be found by taking the sine of the angle and putting it over the cosine of the angle. Store that. You're going to live and die by that. Okay, another quick way to look at this, and that's kind of the beauty of trig, is some people decide to look at it this way. I'm going to make this unit circle 5, because that's what the bottom is, the radius. So this is going to be 5. So in this example, 1 unit would equal 5 something or other spaces. Okay, so that means this 3 is the cosine, which is still the adjacent side, and this 4 is still the sine, which is the opposite. And now you can look very quickly and see that the tangent is the opposite over the adjacent. It all depends on how you want to look at the problem, whichever makes your brain happy. Okay, let's look at another one. -1/5 y. Alright, so -1/5 means that's the x. Now moving over in that direction. You have to decide, are we going to look at this as a unit circle with 1 unit being 5 spaces, or 1 unit just equaling 1 big radius? And it doesn't matter. I tend to like to look at this as my hypotenuse. So then I go to draw it. There's my hypotenuse. And I look at that as 5. But See, we got to find y here. We got a problem. Does y go up or does it go down? So in order to do this information, we don't know if it's positive or negative. We need some more information. And this little purple dot down here tells us that we are going to look in the third quadrant. Aha! So I want my triangle to be in the third quadrant. All right, so now let's fill in the blanks. This is my hypotenuse. I'll put a 5 there. This is in the cosine, in the x value, so I went over -1. Now I got to figure out what this y is right here. Well, it's Pythagorean's theorem because this is a right triangle. So, -1 squared plus y squared is going to get me 5 squared. And hopefully you guys can run through this quickly. Y squared equals 24. When I rationalize that, y is the square root of 4 times the square root of 6. So y is 2 radical 6, but it's going to be -2 radical 6 because I went down. Okay, so now can I figure out what my y value is if I had to write it in this point here? Okay, so I know my cosine is -1 over 5. So what's my sine? My sine is my opposite over my hypotenuse. And if I had to find my tangent, the tangent of this angle is my opposite over my adjacent. So that would be positive 2 radical 6. Then they'll ask you the same question, but they'll word it a little differently. P is a point on the terminal side of an angle. Notice I don't see a unit circle here because it didn't say anything about intersecting with a unit circle because we have to create a unit circle. See, it's just -8 and 15. I'm going to have to create a unit circle. See, on this one, they told me, on the last slide, they told me that it intersects with a unit circle. So I already knew I had an adjacent and a hypotenuse. On this one, I have to create my unit circle. All right, so again, I'm going to estimate. I'm going to go over -8, and then I'm going to go up 15. And there, I've created my triangle. So let's label it -8, 15. And if I want now, I can draw my unit circle, which I have conveniently drawn over here. And it's going to look roughly like that. Okay, so if I want to find now the sine, the cosine, and the tangent that this point creates on a unit circle, this angle right here, I'm going to have to figure out my hypotenuse. And that's right, it's Pythagorean's theorem. Hopefully you remember that 8, 15, 17 is a Pythagorean triple. So the sine of this angle is opposite over hypotenuse. The cosine of this angle is adjacent over hypotenuse. And the tangent of this angle is opposite over adjacent. Okay, let's just look at one more. Let's look at number 6. No, I don't like 6. 5. I like 5. Okay, so this tells me, once again, that I have to create a unit circle. So I have to go over 5. The y value is down -3. And that will create a triangle. So I went over 5, I went down -3, and I have to figure out my radiuses here. It's not 4. It's not a 3, 4, 5 triangle. 5 has to be the radius, the biggest number. So we got to do a little Pythagorean's theorem. R squared equals 5 squared plus -3 squared. So that's 25 plus 9. That's 34. And I can't break that down. So this r ended up being the square root of 34. Okay, let's now go here and let's do the sine, the cosine, and the tangent of this angle. Okay, sine is opposite over hypotenuse. -3 over radical 34. Rationalize that. -3 radical 34 over 34. Cosine, adjacent over hypotenuse. So that's 5 over radical 34. That's 5 radical 34 over 34. And now the tangent simply says take the opposite and put it over the adjacent. Oh, that one came out nice. No rationalization needed. -3/5. Okay, we're going to look at something now. And you have learned that the quadrants are 1, 2, 3, and 4. Well, you're going to learn something new. You're going to also learn that the quadrants are A, S, T, and C. And we'll explain that in a minute. Now, the brighter people may realize that, hey, S is sine, T is tangent, and C is cosine. What does all that mean? Well, let's look at each triangle in each quadrant quickly. Say we drew a triangle in quadrant 1. Then this side of the triangle is positive, and this side of the triangle is positive, and the unit of the hypotenuse is always positive. So in the first quadrant, if I were to do the sine of the angle, it would be an opposite side over the hypotenuse, which gives me positive. If I did the cosine, the adjacent side is positive over the hypotenuse, which is positive, giving me a positive. And the tangent is the opposite over the adjacent, which gives me a positive. All right, so let's go into quadrant 2 now. So I'm going to clone that. I'm going to flip it. I'm going to move it over here into quadrant 2. Now in quadrant 2, the adjacent side is a negative direction, the opposite side is a positive direction, and once again the radius is always positive. So if we did this again, the sine is an opposite over hypotenuse, which is positive. The cosine is the adjacent side, which is negative over the hypotenuse, so that gives me a negative answer. And the tangent is the positive over a negative, opposite over adjacent, which gives me a negative. Okay, let's do this again. Let's go look in quadrant 3. So in quadrant 3, once again, this side is negative, this side is a negative, and this side is a positive. So if I ran through all my sine, cosine, and tangent again, the sine is the opposite side over the hypotenuse, so that's negative. The cosine is the adjacent side over the hypotenuse, so that's negative. And the tangent is a negative value over a negative value, opposite over adjacent, so that gets me positive. One last quadrant to look at. Okay, so if I look in this quadrant, I'm running out of colors. Let's try black. This side is a positive value. I moved over positive, and this side is a negative, and once again the radius is always positive. So the sine is an opposite side over our radius, which is negative. The cosine is a positive adjacent over a positive radius, which is positive. And the tangent is a negative over a positive, which is negative. Now, have you figured out what the AST stand for? All right, it tells you who's positive in each quadrant. So, in quadrant 1, A, everybody is positive. In quadrant 2, it's S. Only sine is positive. Everybody else is negative. In quadrant 3, T. So that means tangent's the only one positive. Everybody else is negative. And in quadrant 4, C, cosine. Cosine is the only one who's positive. Everybody else is negative. Time for the smiley face. We're done.